everyone, welcome to my YouTube channel. Today, I'm solving Leetcode question distribute coins in binary tree. You are given the root of a binary tree with n nodes, where each node in the tree has node.value coins. There are n coins in total throughout the whole tree. In one move, we may choose two adjacent nodes and move one coin from one node to another. A move may be from parent to child, or from child to parent. Return the minimum number of moves required to make every node has exactly one coin. Let's take a look at the example. In this given tree, the root has three coins and then it has two child. So the left child has 0 coins, right child has 0 coins. So we want to return the minimum number of moves required to make every node has exactly one coin. So the minimum number of moves here is 2. So from the root of the tree, we move 1 coin to the left child and 1 coin to the right child. So remember, we can only choose 2 adjacent nodes and move 1 coin from one node to another, which means the move either from parent to child or from child to parent. In this example, the parent has 3 coins, so it gives 1 coin to the left child and then the other coin to the right child. So in that case, each node will end up with 1 coin. In example 2, so the left child has 3 coins, the parent has 0 coins, and then the right child has 0 coins as well. The minimum number of moves is 3. From the left child of the root, we move 2 coins to the root. So that takes 2 moves. Then we move 1 coin from the root of the tree to the right child. So those are the 2 examples. So now we understand the problem statement, how to solve it. So let's try to check the examples one more time. So in the example 1, so the left child has 0 coin to start with, so it needs 1 coin. And then right child has 0 coin to start with as well, so it requires 1 coin. So the total number of coins those 2 child needs are 1 plus 1 equals 2. That's actually our output. In our example 2, in this case, the left child needs to get rid of 2 coins. And then the right child needs to have 1 coin. So the total number of moves is actually 2 plus 1 equals 3. So that's kind of give us an idea how to solve it. So basically, every time we keep track of the number of coins from the child to parent. So in that case, it can be the positive number. So in this case, the number of coins from the left child to parent is positive 2. And then from the number of coins from the right child to the parent node is negative 1, because the right child requires 1 coin. So if we take the absolute value of the number of coins from child to parent, that's kind of like our move. So absolute value of 2 is 2. Absolute value of minus 1 is 1. 2 plus 1 equals 3. That's it. That's our output. So that's kind of the overall idea for solving this question. So let's try to code. So let's use the helper function. So give a root. And then before that, let's try to have a result. So let's keep track of the number of moves. And then we declare this result to be non-local. That's one way to do it. Another way is you can actually select self.result. In that case, you can get rid of the non-local. So for me, I would just initialize the result and then define the non-local. And then, so base case, let's say if root is none, or we can write if not root. So in that case, I just return 0. Else, if the root is not none, so left, right equals helper root dot left helper root dot right. So yeah, let me add one comment. So basically return the number of coins from root to its parent. So maybe let's not call it root. Let's call it node. So the reason why I'm changing the variable name, I mean, it really doesn't matter. We can still call it root, but I just figured it will be a little bit confusing because we are given actually the root of this binary tree as input. So in this case, I'm just utilizing a node. So basically, this helper function is return the number of coins from node to its parent node. So from the node to its parent. So this number can be positive, which means we need to move the coins out of this node and move it to the parent. And it can also be negative, which means, okay, we need to move the coin from its parent to this node because this node does not have sufficient number of coins, so it requires coins to be moved to this node. So this helper function can both return the positive number and negative number. And then this result equals the left, add the left and right to the result. And then we take the absolute value at the result. And then we need to return the left plus right plus the node dot value minus 1. So what does this mean? So this means, okay, for each node, let's say in this example 1, this node is just a parent, just a root of this binary tree, does not have any parent node. Let's assume, what if it has parent node? So from the left node, it needs to move it needs one incoming coin. So the number of coins from the left child to this node is minus 1. The number of coins from the right child to this node is also minus 1. So the result is adding the absolute value, that is 1 plus 1. When we're trying to return, so basically the number of coins from this node to its parent, is, okay, we get the number of coins from the left child, the number of coins from the right child, and then we also have the some coins in this node that's kind of indicated or denoted by node dot value. And then we need to have leave one coin for this node. So that's why the number of coins from this node to its parent is the left plus right plus node dot value minus 1. So after we code our helper function, let's call it for on the root. And then after that, we just return the result.